All right, so we're moving into the system of linear equations that are homogeneous. So homogeneous means equal to zero, the zero vector. So the zero vector, that means every entry in the vector is zero. So this is an important fact, huge deal. The homogeneous equation always has the trivial solution. So it's true that if I put x equals 0 in here, take a matrix A, multiply it times the zero vector, I will always get 0. So this is so important, but it's so trivial, but it's something you need to remember. So what we're going to be interested in is exploring the non-trivial solutions of this homogeneous. So it's only with homogeneous that we have this trivial solution. So a homogeneous equation has a non-trivial solution, meaning not zero, if and only if the equation has at least one free variable. So let's work more on these free variables that we've been doing. I've just been before saying x3 is equal to free variable. All right, so here I have a system. I put it in the augmented matrix. Here's the RREF form with your calculator. I get to here. So now we know, because I have three variables, right, x1, x2, x3, I only have two pivot positions. So since there's only two pivots, that means one of them has got to be a free variable. So here we go. So I solve for these basic variables. So this first row gives me this information. 1 times x1 minus 5 times x3 equals 0. The second row gives me this information. 1 times x2 plus 2 times x3 equals 0. So I'm always solving for my basic variables, my pivot positions. So solve for x1, solve for x2. And I know x3 is free. So x1, so first off, this is a really big deal. So write out what your x is equal to. In this case, x has is an R3. So there's three terms in it. So x1 is equal to 5x3, x2 is equal to negative 2x3, and x3 is itself. So now we factor the x3 out, and now I have the parametric form of the solution. So every solution is a scalar multiple of this vector here. Remember, because x3 can be any number. So we say the solution set is the span of this vector, which of course includes the trivial solution, which is x3 equaling 0, which gives us the vector 0. All right, let's continue on with some examples. So here I have a system, only has two equations, but it has four unknowns. So I know I'm not going to find a unique solution. So I put it together in my augmented matrix, RREF, get to here. So this first row gives me x1 plus 2x3 is 0. The second row gives me x2 minus x3 minus x4 equals 0. All right, the basic variables are the pivot positions. So these are the two that you solve for. So I solve for x1 and I solve for x2. All right, so this is a really important part of the problem solving, making sure you remember how many terms, how many entries are in your x vector that you're trying to solve for. So there's 4. So x1 is equal to negative 2x3, x2 is equal to 2 of them, x3 is itself, x4 is itself. So I'm not writing it down, but x3 is free and x4 is free. So you have to kind of keep that in mind, and that's why you let x3 and x4 equal themselves. So now I need to break it up into which have x3 and which have x4 in it. So I break it up. So I have negative 2 times x3, 1 times x3, 1 times x3, and then over here for the x4s, I have 1 times x4 and then 1 times x4. So there are two vectors that all the solutions are linear combinations of. So the solution set is the span of these two vectors. And of course, this always includes the trivial solution. So the trivial solution comes in when I get 0, and I'm always allowed to choose any number for these x3 and x4. So if those were 0, that would be in the solution set. All right, one more. So this is almost what I would call the simple stupid case. There's not much here. There's only one equation and there's 3 unknowns. So no matrix to be needed, but let's go and find and solve for our basic variable. So my basic variable is going to be x sub 1. And so x1 is equal to 0.3x2 plus 0.2x3. So again, this is really important to remember. How many x's are in my solution? There's 3. And so I can rewrite x1 as 0.2x2 plus 0.2x3. x2 and x3 are free variables. They're there, so they represent themselves. Then break it up. So which ones have x2 in them? And so that's the vector x that's multiplied by x2. And then break it up, so the vectors that have x3 in them. So these two here. So this solution set is the span of v and w, these two vectors.